Now if we look at this in a wee bit more detail then, if we put voltmeters, and I've connected a voltmeter to the primary coil and to the secondary coil here, we can actually measure the voltage up across the primary coil and the voltage across the secondary coil when I turn on the lab pack. So again, there's my power station on, we're getting 10 volts on the primary coil. If we look at the secondary coil, I'm actually getting 200 volts, 201 volts at the secondary coil, 10.7 volts at the primary coil. So our voltage has been stepped up 20 times. Why 20 times? Because our coil, primary coil and our secondary coil, the turns ratio was 1 to 20, which means the ratio of the voltages is 1 to 20. So 200 volts is the voltage applied to these power lines, which means we've got 200 volts at the other end, so therefore we've got to step it down again at the other end. So let's have a look at the voltages across the coils in the transformer where we're stepping the voltage down at the village end. And there's a step down transformer, and if we have a look at our voltmeter readings, then the primary coil of the step down transformer is again reading about 200 volts, and our secondary coil is reading about 10 volts. If I change the scale on that, we're still losing energy. We're losing energy as sound, we're still losing energy as heat in the wires, but it's a much more efficient system of transferring energy over long distances. So we step up the voltage at the power station end, transmit it at high voltage, and then step it down at the village end. And the final question really is then, what happens to the current? If we've stepped the voltage up 20 times, then what happens to the current? So we've got our same arrangement as before. We've got our power station, our step up transformer, our power lines, our step down transformer, and our bulb at the village end. At this time I've got in 2 ammeters so that we can measure the primary current, that's the current in the primary coil, and the current in the secondary coil, to see what happens to the current when we use a step up transformer. So if I turn on the power, on my left hand ammeter there is measuring the current in the primary coil. Now I've got this ammeter set up on a 5 amp scale, so we're using the bottom scale on the ammeter. It reads up to 5 amps. So using that bottom scale, you can see that my current is about 1.6 amps. And if we go over to our secondary coil, the current in the secondary coil is being measured by an ammeter which is on a 1 amp scale. So the top scale is reading up to 1, and so that ammeter is reading 0.08 amps. The current has been stepped down 20 times. By sending the current at a much smaller value, we don't lose as much energy in the wires due to the heating effect of the current. So once again, we've stepped the voltage up 20 times with the transformer. By doing that, we reduce the current 20 times, and that means the same amount of energy can be transferred, because power, remember, equals current times voltage. And then finally, down at the village end then, we've stepped up the voltage to reduce the current, transmit it along the national grid, step it down at the village end, so we're reducing the voltage back down to a usable value. And let's see what's happened to the current. So here's our current at the village end. It's coming down from the power lines, 0.08 amps, top scale. And our secondary current, which is on the 5 amp scale, That's the bottom scale this time. Again, we're back to 1.5 amps. So again, the current has been stepped up by a step down transformer.